In this video, I'm going to show you how to get started doing linear regressions using the statistical software known as R and RStudio. What I'm going to cover is I'm going to show you how to download and install R and RStudio. I'll show you how to load the necessary packages to do the linear regression and to view the results. Then I'll show you how to import the data from Excel into RStudio. Then I'll show you how to actually do the linear regression, and then how to view the results. So let's get started. So let's say that you have some data, and that data is in an Excel sheet, and it looks something like this, where you have several variables, and you are interested in seeing how the multiple independent variables influence the dependent variable. In this case, we'll treat happiness as the dependent variables, and we're interested in how diversity, GDP per capita, and corruption influence the happiness of a country. So, to do that, we're going to need to use the software R and RStudio. So I'll show you how to download R first. Whoops. So just do a Google search for download R. It'll take you to r-project.org, and you're going to click this link at the top that says to download R. And there's a bunch of different mirrors, a bunch of different places to download. Scroll down till you get to the United States mirrors and choose the first one. And then choose the link for the operating system that you use. And we want to download the base version of R. So go ahead and click base. And we're going to download version 3.6.2 or whatever version is the most recent version at the time of watching this video. So go ahead and click this link, and you'll see that R will download in your Downloads tab down here, or if you're using another web browser, wherever downloads go. Wait for it to finish downloading, and then click the download button here. Just click this, and it'll open up the installer. Select your language, and proceed through all of the steps just like you would install any other program. I've already done this, so I'm not going to do it again. So we're going to exit that setup. Now, the other thing you're going to need is RStudio. So to download that, just Google search download RStudio, and the top link is rstudio.com, and you're going to download the free version, RStudio Desktop. So just click download here. If you have something other than Windows, you can find it down in this list, but I have Windows, so I'm just going to click this top link here, and it's going to download the executable installer, and it's going to be the same thing. Wait for this to finish downloading, click the button to run the executable file, follow the prompts on screen to install RStudio. So once you have installed both of those, you'll notice that R comes with two desktop icons. Neither of these really matter because we're only going to be using RStudio. RStudio is sort of just like a mask that goes on top of R that makes it more user-friendly to use R. So we're going to use RStudio. So the first time you open up RStudio, double-click it, and you're going to get a screen like this. You're going to have an area to type stuff over here. You're going to have a panel over here, your global environment. And then you're going to have a panel over here where you can view a lot of things and mess with packages. So the first thing we're going to do is we're going to open up a new script file, create a new R script. So you're going to open this up, and it's going to give you this little text box area to type in. And what this lets you do is it lets you write multiple lines of code that do interesting stuff, and then you can execute all of that code at once by highlighting it and hitting the run button. So this allows you to execute multiple lines of code at the same time. So remember, our goal is to take this data and do a linear regression on this data. So the first thing that we're going to do is install two packages that are going to be necessary to accomplish this goal. And RStudio is very convenient because it has this packages tab down here and this install button, which you'll click, and you can search for the packages that you're going to need. So the first one we're going to need is the LME4 package. This is for linear regression. So you just go ahead and hit install, and it's going to do its thing. And once it's done, you're going to get this line that says package LME4 successfully unpacked and MD5 sums checked. That's good. It will tell you where the packages were installed. That's not really important unless you are going to be messing around with your packages later. The important thing is that it has been successfully unpacked and the sums checked, so you know you're good to go. The other package that we're going to need is a package called sjplot with a capital P. And this is going to let us visualize the results in a pleasing manner. So we're going to go ahead and install this package, and it's going to do its thing. It's going to install, and you're going to get this same package sjplot successfully unpacked and MD5 sums checked. Now, when you run this, because you will have a brand new version of RStudio, you may see that it installs a bunch of other packages before it installs sjplot. That's because sjplot has a few dependencies. That means it sort of works on top of other packages. So you may see that it installs a bunch of other packages, and then finally at the end it will install sjplot. And at that point, you know you'll be good to go. So now we have the packages that we need, and we need to sort of load them into our current session so that R can work with these packages. So we're going to do that just by using the library function, and then in parentheses we're going to put the name of the package that we want to load. So the first one is going to be LME4, and we're going to do another line, library again, and the second one was sjplot, just like that. So let's go ahead and run these two lines just to make sure everything is working fine. Run them. Okay, and so we didn't get any errors, nothing bad happened, so we know we have successfully loaded these packages into our current session. So we have downloaded and installed R in RStudio. We have downloaded and loaded the necessary packages. Now the next step is to get that data from Excel into RStudio so that we can start working with it. So there's many different ways to do this, but for a data set that is this simple, we'll do a very simple method of getting data into RStudio. I actually have two versions of RStudio open. Let me close this one. That was from a trial run. Don't save. Okay, we're going to do this from scratch. So we're going to want to create a variable to save all of our data in, and we'll call that variable myData. And in R, we use this arrow to assign something, excuse me, to that variable. So it's just a less than sign with a hyphen. So that means whatever we write over here is going to be assigned to this variable that we're calling myData. So what we're going to do here is we're going to use a function called read.table. And this function is going to take three parameters that are going to tell it what table to read and how to read the table. So the first parameter is the file parameter. And we're going to say file equals clipboard. We're going to do this because this is a very easy way to access the file that you want. So it just means it's going to, when you copy something to your clipboard and that information is saved in your clipboard, that's where this is going to go find it. It's going to go to your clipboard, and whatever's in your clipboard, it's going to load that. So what we're going to do is we're going to copy all of the data in our Excel file, Control-C, copy it. It's now in our clipboard. So that's good. Now the second parameter we need to specify is the separator parameter, SEP. And all Excel files are tab delimited. That means that all of the individual cells are separated by a tab. So if you select a cell and you press the tab button, you notice you'll go over to the next cell, tab, next cell. Excel files are tab delimited. So we need to tell this function to be expecting tab delimited data. So in quotation marks, we're going to put a backslash and a T. So it knows to expect tab delimited data. Now the final parameter is going to be header equals true. True needs to be in all caps. You'll see it turn blue when you've done it right. This just means that the top row of the data are the labels of the variables. These are the headers for each column. So it knows that when it reads the first row, these are the names of the variables. So we've set header equal to true. So let's go ahead and run this line and make sure everything works fine. Everything has worked fine. So notice now in the global environments, we have my data. This is a variable that we've created. And if we want to, we can double click this and we can see that it has been successfully imported into RStudio. So now the data is loaded into RStudio. Now we want to do a regression. This is where we're going to make use of this LME4 package. So again, we're going to create another variable. I'm going to call it model. You can call it whatever you want, but we're creating a linear model, so I'm just going to call it model. And we're going to use the LM function, which stands for linear model. So the first parameter that we're going to pass into this function is going to be the formula of the linear model. And so the way we're going to do that, let's go ahead and look here at the variables that we've chosen. Our dependent variable is this happiness variable. So we're going to write that in first. We're going to say happiness, and then we're going to separate that with a tilde, which is the squiggly line next to the 1 on your keypad. And now we're going to enter all of the independent variables. So we have diversity, GDP per capita, and corruption. And we're going to separate those with a plus sign. So we'll write diversity plus GDP cap. Now RStudio is case sensitive, so whatever you name the variables, make sure that you type them exactly as they are named. So GDP cap plus, and the final one was literacy? No, corruption. The final one was corruption. Okay, so this right here is the first parameter. It is the formula. It basically means that we're going to investigate the relationship between diversity, GDP cap, corruption with happiness. And, you know, the advantage of a regression is that instead of doing a simple bivariate correlation, like just between diversity and happiness, this allows the model to control for these other variables and take them into account when determining what the relationship between diversity and happiness is. So it's able to look at all of the variables at the same time and sort of separate them out, separate their effects out, so that relationships don't sort of get confused together. So then the second parameter we're going to pass into this function is the data parameter, which is going to tell this function where to get the data. Where is happiness located? Where is diversity located? Well, it's located in this my data object that we created earlier. So we're just going to say data equals my data. So now it knows where to find the data. So let's go ahead and run this line of code and make sure that everything works fine. And no errors. We see that it ran this line of code. Everything is fine. And it even created this model variable here. So we've done it. We have created a linear model. We have done a linear regression using 3 independent variables and 1 dependent variable. But now we want to see what the results are. So the simplest way to do that is to use the function summary. And then in parentheses, we will give it the model that we want to summarize it. We called our model model, so we're going to write that in the parentheses. And we will go ahead and highlight this and run it. And our output will give us this nice output that tells us what the coefficients are for each of the variables. So the way you can think of this is if you have a positive number, you can say that high levels of diversity are associated with high levels of happiness. Here we have a negative number, so we can say that high levels of GDP per capita are associated with lower levels of happiness. And then here with corruption, this one's interesting. We have a positive number, so we can say that high levels of corruption are actually associated with high levels of happiness. Now, to be clear, this column right here is very important. This column shows you the p-value of each of the coefficients, and this tells you whether the relationship is statistically significant. And what you're looking for are small p-values. If the p-value is typically the cutoff used is 0.05. This is the most commonly used cutoff value, although others can be used. But typically, you would look at this number, and if this number is less than 0.05, then you would say that this relationship is significant. And in the case, now, again, to be clear, these numbers are sort of made up numbers. I pulled some of them off Wikipedia. I made some of them up off the top of my head. So this isn't expected to be a great model. There's also very few countries in this model. Ideally, you would like to have more so that you can really parse out the true relationship. But this is just an example to show you how to get started. So none of these variables are actually significant. It's very important that you pay attention to this number, because if this number is greater than 0.05, then the relationship is not significant. You can also look at the statistic for the overall model itself. So the overall model also has a p-value, and this number is also bigger than 0.05. So we know that this model in general is not a statistically significant model. So it's not a great model, but that's okay, because all we're trying to learn here is how to get the data in and how to do a linear regression. I'll let you get your data how you want them and run your own models. So the last thing I'm going to show you is another way to visualize this data that's a little bit more visually appealing and can also be exported into something like Microsoft Word if you want to include it in a paper that you're writing, for example. So that's where this package sjplot comes into play. So we're going to use the tab model function, which is found within the sjplot package, and we're going to pass it the variable that contains our model, which is just called model. So model, and if we run this line of code, we get an output that looks like this. It's basically the same information that's over here, but it's a little bit more visually appealing. And one convenient factor is that if you select everything and you copy it, and then you open up a Microsoft Word file, blank document, and you paste it, you get a Microsoft Word table that you can then interact with. You can change the column widths and make it bigger. So that's great. You now have an output that you can work with in Microsoft Windows. And there are many other parameters that can be passed to this tab model function. For example, you can say title equals, and then you can give your results some title, whatever you want them to be called, and you can run this line of code, and you'll see that a title has been placed. And there are many, many other parameters that can be passed into this function. Remember to always separate them with a comma. Every parameter is separated by a comma, but there are many other parameters that can be passed into this function that can customize the way this output looks, but I'll leave it to you to sort of Google and figure out how to change those parameters. This is just to get you started. So I hope that was helpful. To review, we learned how to download and install R&R Studio. We learned how to load the necessary packages in order to do a linear regression. We imported the data from Excel. We did the linear regression, and then we viewed the results. I hope this video is helpful to you. If you have any questions, feel free to just leave a comment and we'll answer those. So thank you very much for watching.